Okay, so part 2, picking up with number 16. Alright, so when it says simplify this radical expression, when you have a binomial in the denominator, what you have to do is multiply the top and the bottom by the conjugate, which is 5 minus 3 square roots of 5, on top and bottom. So what we're going to do is distribute it out. Okay. So on the numerator, I've got 2 times 5, which is 10, and then I've got 2 times negative 3 square roots of 5. 2 times a negative 3 square roots of 5 is a negative 6 square roots of 5. Okay? Now I'm going to distribute the square root of 5. Square root of 5 times 5 is just 5 square roots of 5. That's not inside the square root, so it has to stay outside the square root. Square root of 5 times negative 3 square roots of 5. Square root of 5 times a negative 3 square roots of 5. Well, square root of 5 times square root of 5 is 5. Times your negative 3 is a negative 15. Okay? And then in the denominator, remember these are conjugate pairs, so the middle two terms should cancel each other out. 5 times 5 is 25. 5 times a negative 3 square roots of 5. 5 times a negative 3 square roots of 5 is a negative 15 square roots of 5. And then 3 square roots of 5 times 5 is the same thing, only it's a positive. So positive 15 square roots of 5, which will cancel out with the second term. And then 3 square roots of 5 times negative 3 square roots of 5. 3 square roots of 5 times negative 3 square roots of 5. That's a negative 9 times 5, which is a negative 45. Remember, you can type that in the calculator if you want to check and make sure that you got it right. Calculator will do that. Unless it's something like this, in which case it will not write it as a radical. So let's combine like terms in the numerator. 10 minus 15 is a negative 5. Negative 6 square roots of 5 and positive 5 square roots of 5 is a negative 1 square root of 5. Negative 6 plus 5. And then 25 minus 45 is negative 20. I don't like the negative in the front, so we float it up, and we put it right here. And that's like saying negative all of that, so let's distribute that and say a positive 5 plus 1 square root of 5 is just square root of 5 over 20. And there we go. Now if you want to, you can say 5 over 20 plus square root of 5 over 20, which is 1/4. But sometimes people do this, they say 1/4, and then that's divided by 4, but it's not. It's still divided by 20, so I would just leave it like that. Okay. Now on 17, we want to multiply these two out. So it's the same thing as this over here, just only multiplying these two. So negative 2 times 3 is a negative 6. Negative 2 times a negative 2 square roots of 3 is a positive 4 square roots of 3. Okay? Now I've got 5 square roots of 3 times the 3, that's 15 square roots of 3. And then I've got 5 square roots of 3 times a negative 2 square roots of 3. 5 times negative 2 is negative 10. Square root of 3 times square root of 3 is 3, so that's a negative 30. Next thing I want to do is, or last thing I want to do is combine like terms. So I've got negative 6 and negative 30, that's negative 36. 4 and 15 is 19, so 19 square roots of 3. And that is my final answer. Okay? Alright, let's move on to 18. Write the expression in radical form. So remember, when you have a rational power like this, 4/5, the root is the bottom, just like on a tree, the roots are on the bottom. So it's the 5th root of y to the 4th, like that, or the 5th root of y to the 4th out there. So either one is correct. So by the same token, if I can go from the power to the root, then I can go from the root to the power. So this is 1 over y to the root on bottom, power on top. 8/3, but since it's in the denominator, I want to write it as y in the numerator, and that just makes the power negative, to the negative 8/3. So when you have 1 over y to the 8/3, bring it to the top, that's y to the negative 8/3. Okay, now let's talk about 20. So on 20, what you have to do is just, some of you can skip a lot of steps, or you can combine some steps that I'm going to do. I'm just going to work it out step by step, so you know what you can do, and if you skip some steps, just make sure you get the same answer as I do. So I'm going to distribute the power of 3 because inside this big parenthesis I have another set of parentheses, so I need to take care of that first before I can take care of the big set. Okay, so I've got x to the negative 2 to the third, that's x to the negative 6. Y to the third, that's y to the ninth. Z to the negative 1 over x to the fifth, y to the negative 2, z to the positive 4, all to the negative 2. Now, because this is all multiplication and division, we can distribute the power. You can't distribute when you're adding and subtracting, but you can when you're multiplying and dividing. So I'm going to distribute this. This is x to the positive 12, y to the negative 18, and negative 1 times negative 2 is positive 2, so z to the positive 2. Okay. Now in the denominator, I'm going to distribute the negative 2 as well. Negative 2 times negative 5 is negative 10. Sorry, negative 2 times positive 5 is negative 10. Negative 2 times negative 2 is positive 4, so y to the positive 4. And negative 2 times positive 4 is negative 8. So what I'm going to do is now rewrite. So everything that has a negative power needs to move. Everything that has a positive power needs to stay. So that stays, that moves. That stays, that moves. That stays, that moves. So now at this point I need to combine. Do you notice how, I mean there's no, if say I did end up with something like x to the 10th and then on the bottom I had x to the second. Remember at that point what you have to do is you have to cancel 2 of those out with 2 of those and you get 8. But in this case all x's are on top, all z's are on top, and all y's are on bottom. So it's just a matter of simplifying. X to the 12th times x to the 10th, you add the powers, x to the 22nd. Let me go ahead and put that other way. Okay. And then, so x to the 22nd, z to the 2nd and z to the 8th is z to the 10th, 2 plus 8, and then y to the 18th and y to the 4th, that's y to the 22nd. So my answer is x to the 22nd, z to the 10th, over y to the 22nd. Okay? Alright, now this is solving equations and radical equations. So there's some things to think about. So the first thing you need to think about is the fact that you have this square root and the variables underneath it. The only way you can get rid of a square root is by squaring, but you can't square until you have the square root by itself. So I have to get rid of the number in front of it, which is that negative 2. So I'm going to add 2 to both sides and get 8. 8 is the square root of 7m plus 1. So now I want to get rid of the square root, so I square both sides. So if I square this side and square that side, those two cancel each other out, and I'm left with 64 equals 7m plus 1. Now, so far as solving this is just a linear equation, so minus 1, 63 equals 7m. Divide by 7. If you divide by 7, you get 9 equals m. So if 9 equals m, then what I need to do is it says check for extraneous solutions, so plug it back in. 6 equals negative 2 plus the square root of 7 times 9 plus 1. 7 times 9 is 63. 63 plus 1 is 64. The square root of 64 is 8, and 8 minus 2 is 6, so this does work. Okay. Now on 22, what I want to do is, again, get rid of the square root, but in order to do that on this one, when I square both sides, the dangerous thing is to remember that when you square a side, you have to square the whole thing. And to square something means to multiply it by itself. So x minus 1 times x minus 1 equals 4x minus 4. So then I'm going to distribute this out. X squared, negative 1x, negative 1x, and positive 1. So I've got x squared minus 2x plus 1 equals 4x minus 4. Okay, you have a quadratic, and if you have a quadratic on one side, you want to get everything on the same side as that quadratic so that you can factor it maybe. So what I want to do is I want to minus the 4x from both sides and add the 4 so that nothing is left on this side. So I've got x squared minus 6x plus 5 equals 0. So if I want to try and factor this to solve, then I'm looking for the factors of the last term, 5, the add up to the middle term, negative 6. So I'm thinking 1 and 5, 2, nope, just kidding. 1 and 5 are the only multiples of 5, the factors of 5. So then negative 1 and negative 5 add up to negative 6. X minus 1, x minus 5. Because this is just a 1, we don't have to divide by anything, the answers are 1 and 5. Okay, but it does say to check, so I'm going to plug in 1 and plug in 5. If I plug in 1 right here, you get 1 minus 1, which is 0, equals the square root of 4 times 1 minus 4. 4 times 1 is 4, 4 minus 4 is 0, so that works. Okay, now let's check 5. 5 minus 1 is 4, and then the square root of 4 times 5 minus 4 is 20, minus 4 is 16, and the square root of 16 is 4. So they both work. Okay, so your answers are 1 and 5 on 22. Okay, let's talk about square roots, graphing square roots. When you think about your transformations, remember that on the inside, you go the opposite direction. So if it's plus 6, that means go to the left 6. Okay, so go to the left 6. But then on the outside, it's exactly as it seems. So plus 1 goes up 1. So I'm going to go left 6 and up 1, put my dot. Now this is a square root, and you have to remember, I know that the square root of 0 is 0, and the square root of 1 is 1. The square root of 4 is 2, and the square root of 9, 5, 6, 7, 8, 9 is 3. So if I can remember the pattern, to the right 1, up 1, to the right 4 from the center, up 2, and to the right 9, up 3, then I can graph this. So to the right 1, up 1, to the right 4 from the center, 1, 2, 3, 4, up 2, and if that's 4, 5, 6, 7, 8, 9, up 1, 2, 3, just remember to go from there, start here, and then go to draw your arrow. This doesn't have an arrow on the side, it just stops. And there's my graph. Now it does say domain and range. Remember that domain is left and right. So the farthest to the left, this function goes as negative 6, and the farthest to the right is positive infinity. Range is up and down. The lowest the function goes is 1, and the highest it goes is infinity. Okay. Now in this one we have a little bit more transformations going on. You've got this minus 3, which means go to the right 3. You've got this minus 2, which means go down 2. You got this negative, which means flip over the x-axis, and you got this 2, which is a vertical stretch by a factor of 2. So when I do this, I'm going to go to the right 3 and go up, down 2, 1, 2, and that's my starting point. And then because it flips over, that means instead of going this way, I'm going to go down. Right. Wait a second, I gotta make sure my door's shut. Okay, never mind. Sorry, someone came to the door. Okay, now, it does mean it flips. One thing to think about though is that vertical stretch means normally you go to the right 1, up 1, to the right 4, up 2, and to the right 9, up 3. But we're going to multiply it by a negative 2. Which means I'm going to go down 2, I'm going to go down 4, I'm going to go down 6. Okay, if I can reach that far. So when I go to the right 1, I'm going to go down 2. To the right 1, down 2. To the right 4, go down 4. So 1, 2, 3, 4, down 1, 2, 3, 4. That's as far as I'm going to be able to see. So I just connect those and draw an arrow. Okay, oh, was I out of range on that? Okay, so the right 1, up 1, multiply it by negative 2, and I'm going to go down 2. To the right 4, down 4, because 2 times negative 2. To the right 9, down 6, but we can't see that, so we'll just do domain and range. Domain is left and right, so the farthest to the left I go is 3, and then the farthest to the right is infinity. Range is up and down. The lowest I go is actually negative infinity, and then the highest you go is negative 2. Remember, low to high. Okay. Okay. On number 25, it says find f of g of x. So f of g of x means this is the inside function g, and I want to plug it into f. So what this is f of g of x means wherever you see an x in f, you replace it with g. So f of g of x means 2x plus 1 instead of x, which is g of x. And remember, when you square something, you've got to multiply it by itself. Sorry, my hand is all in the way. So 2x plus 1 times 2x plus 1, and then minus 5. So let's multiply that out. 4x squared plus 2x plus 2x plus 1 minus 5. So I've got 4x squared plus 4x and then minus 4. And that is my answer. Okay, it just says find the function. It doesn't say simplify, it doesn't say solve. It says find the function. Okay, same thing, f of g of x means I'm going to take g of x and plug it in for x in f. So it's 4 times the square root of 2 times x, which is 8x plus 10, and then minus 1. Now sometimes you guys start taking the square, you square this to get rid of that square root, to which I would apply y. I mean, you can't, there's no equal sign, we're not solving an equation. This is just f of g of x. We're saying what the function is. Okay? The only time you can start getting rid of operations is if you're solving an equation. Okay, so all I need to do is distribute and simplify. 4 times the square root of 16x plus 20 minus 1. So the answer is 4 times the square root of 16x plus 19. And there it is. Okay. So let's find these right here. Now, this is similar to this right here, except for it's a little bit easier because this just has a number inside. So what you have to do is just remember, inside first, find g of 4, which means plug 4 into g. So g of 4 is 4 squared minus 5, which is 16 minus 5, that's 11. Now, if g of 4 is 11, then that means find f at 11. So if I plug in 11 right there, then I've got 5 times 11 plus 2. 55 plus 2 is 57. So the answer is 57. Okay? Inside function first. Now what you have to remember is that this is the same thing. This means g of f of 0. Okay? So you want to find the inside function first, f of 0. So I'm going to go to f, and I'm going to plug in 0. f of 0, 5 times 0 plus 2. 5 times 0 plus 2, that's just 2. So now I'm finding g of 2. So now I'm going to plug 2 into g. So 2 squared minus 5, that's 4 minus 5, that is negative 1. And there's my answer. Okay. 29 says find h of g of 9. So what I'm going to do is first find the inside function g of 9, which means 9 squared minus 5. That's 81 minus 5. That's 76. Okay. So that g of 9 is 76, so I need to find h of 76. So I've got 2 times the square root of 76 minus 1. 76 is, I guess 4 times, let's see. 76 divided by 2 is 38. And that divided by 2 is 19. So it's 4 times 19. The perfect square that goes into 76 is 4. So the square root of 4 is 2. And then I'll leave the square root of 19 in there. But then there's also this 2. So I've got 4 square roots of 19 minus 1. And there's my answer. Okay. Find the inverse of each function, state the domain and range of the function and its inverse. So first, let's talk about this function's domain and range. This is a parabola. Remember, parabolas look like the U. But it's shifted to the right 3 and up 1. So if you shift to the right 3 and up 1, this is what it looks like. So what is its domain and range? So for f, domain and range. Well, domain is left and right. It's all real numbers. Range, though, the lowest it goes is 1. And then the highest it goes is infinity. Okay, so that's this domain and range. Well, without even knowing what the inverse is, I already know that the inverse, domain and range, are just switched. The domain is 1 to infinity because it was the range for that one. And the range is all real numbers because it was the domain of that one. Remember that the x's and the y's just switch. So do the domains and ranges, okay? Okay, so then on this, find the inverse. First thing you need to do is remember that that's a y, or the same thing as a y. And when finding domain, or finding an inverse, the first thing you do is switch them, x and the y's, and then solve for y. Solving for y makes you undo every operation in the opposite order. So on a minus 1, you want to get rid of the square by square rooting, but remember when you take a square root there's 2 answers. So I've got plus or minus the square root of x minus 1 equals y minus 3, because they cancel each other out. And then I want to add 3. Now when I add 3, I've solved for y, which means I have the inverse. So f inverse of x. And then there's this domain and range. Okay, so switch the x and the y, and then solve for y. Undo every operation. Okay, state if the given functions are inverses. You've got a couple different options. One option, though, is probably the easiest one, is to switch x and y for one of these and solve for the inverse. And if you get the other function, then they are inverses. So if y equals 2 minus 3 halves x, switch the x and the y. X equals 2 minus 3 halves y. Solve for y. So I'm going to minus 2. X minus 2 equals a negative 3 over 2y. I'm multiplying by negative 3 and dividing by 2, so I'm going to undo the division by multiplying by 2. So I've got 2x minus 4 equals a negative 3y. And then I want to divide by this negative 3 every term. So this is a negative 2/3 x, and this is a positive 4/3, which is that. So, yes, they are inverses. Okay, let's talk about 32. On 32, it says rewrite each expression in exponential form. This is log form. Remember, base of the log is base of the exponent. It can't be 1 over 64. It's 8 to the negative 2 has to equal 1 over 64. So to go backwards, so 8 to the negative 2 equals 1 over 64. Log base, the base of the exponent is base of the log, 19. It can't be b, so it's got to be a equals b. Okay, so it's just a matter of going back between log and exponential form. Okay, so 34. Evaluate each log expression, or each expression. Log base 6 of 216, well, here's what I know. 216 is the same thing as saying I want to be able to rewrite 216 as 6 to some power, and if I look right here, 6 cubed is 216. Because remember, log base a of a to the b is just b. Those all cancel each other out. So those cancel each other out. The answer is just 3. Okay. Well, right here, this is 6 to the first power, but it's in the denominator, so if I bring it up, this is log base 6 of 6 to the negative 1. They cancel out, and the answer is negative 1. So if it's in the denominator, bring it up as a negative power. This one's a little bit tricky. What you have to think of is 5 is 125 to the what power? Well, here's what I know. I know that 5 cubed is 125. So if 5 cubed is 125, does it make sense that if I take the cubed root of both sides, then I get 5 equals the cubed root of 125? Which means 125 to the 1/3 power is 5. So if I look at this, I could say this is log base 125 of 125 to the 1/3 power, because the cubed root of 125 is 5, and so I end up with 1/3. And there you go. Okay, now let's do condensing and expanding, and that'll be the end of part 2. Okay, for this right here, you have to remember a couple of rules. Log of m plus log of n is log of m times n. Okay? So when two logs are separated by addition, you combine them using multiplication, but when they're separated by subtraction, consider this to be the division bar, log of m divided by n. Okay? And last thing, if you have a power, then it can be brought back to the, if you have a number in the front, it can be brought back to the back as a power. Okay? So using those rules, let's talk about this right here. I've got two logarithms separated by addition, which means inside one logarithm I'm going to have multiplication. So these two things are multiplied by each other. Now anytime you have a number in the front, you need to move it to the back as a power. So that's w to the 5th times u to the 1/4. But remember, u to the 1/4 is the same thing as saying the 4th root of u to the 1st. And there you go. That's the answer. Okay? So let's do 38. Okay, I've got three different terms, the square root of x, h to the 4th, and y to the 5th in the denominator, which means I need to have three logarithms. Log base 7, log base 7, and log base 7. Now the first term is x, the square root of x, which remember that's an understood 2. That's the same thing as saying x to the 1 over the power, or the root. Power over root, 1/2, right? But powers go to the front. I'm going to go ahead and write it as x to the 1/2 here, h to the 4th here, and y to the 5th there. But remember, powers need to come to the front. Last thing is how they're separated. They're combined using multiplication, so these two should be added together. These are being divided by that, so that means this needs to be subtraction. And then I'm done. And that is your answer. And that is the end of part 2, so we'll pick up part 3 with number 39 on.